All right. Yeah. Okay. So it's 2:07 now. I think we can get started with our workshop. So welcome everyone to our 3D printing workshop. Um, we're really happy to have you here. Thanks for coming. Um, yeah, let's introduce ourselves. I'm Ken. I'm one of the board members for YaleMakes, and I got started 3D printing. Really in at the beginning of high school, and I did a lot of 3D printing for my robotics my robotics team, and so I've sort of taught myself some 3D printing things over the years, and I'm interested in really sharing all that with you guys.
I'm David. Hello, everyone. I'm David, and also member of YaleMakes. And I just started with 3D printing because I'm an artist, and the ability to pretty much print anything you want is just such an amazing opportunity. And even though I'm a psych major at Yale, I really love to make art with 3D printing. So that's kind of where my interest lies. So if you have any questions about that, hit me up.
And hello, my name is Miriam. I am another one of the board members for YaleMakes. I got started with 3D printing through robotics. I was very involved in robotics throughout high school, and 3D printing is a magnificent and really easy way to manufacture parts, because normally you would have to make parts out of metal or other materials like that. But with 3D printing, you can make some really complex parts that are sturdy, they function well, and it's super easy in terms of manufacturing purposes. So that's kind of how I got interested in 3D printing, and then as well as CAD, because CAD, computer aided design, is how you can basically create your own parts to print. And yeah.
Yep. And we'll be going over that throughout the workshop. All right, yeah. So leading into that, we have this is our plan for today. We'll start with sort of a overview of 3D printing, sort of the very basics. Then we'll move into how you can get models to 3D print, and then how you can design models with CAD, as Miriam mentioned. And then we'll go through all the steps of getting from your design to the final printed 3D printed object. Yeah. So I'm going to start off with the very basics of how 3D printing works. So I'm going to preface this by saying that 3D printing is a very broad term. It covers a whole bunch of technologies. So for now, I'm going to explain sort of the basics of one 3D printing technology that is very commonly used and is probably the most accessible to hobbyists and to beginners to 3D printing. So here's sort of the theory behind 3D printing, right? So imagine you have a hot glue gun, and you probably all used a hot glue gun before, and you have that the basics of the hot glue gun. You have some sort of heating element that heats up the hot glue to really high temperature, and then you pull the trigger, it squirts out the hot glue. Okay, so that's in principle that's very similar to sort of the main printing mechanism for the 3D printer. So we have the print head here on that picture on the left side, and that you can sort of compare, sort of as an analogy to the hot glue gun, and but instead of printing out instead of melting and pushing out hot glue, we're going to use plastic, and the plastic we call it filament. It's it comes in a spool. It's essentially this really long continuous strand of plastic that you feed into this print head, and that melts down the plastic and pushes it out through the nozzle. So that's great now that you have the plastic being pushed through the nozzle, but now you need to move it around, right, to build up some sort of design. So then here's a photo of the plastic melting and coming out. So yeah, and as I mentioned before, right, this is that entire assembly that heats up the plastic. That's called the hot end, and that gets to really high temperatures. Depending on what type of plastic you're printing, it will get up to around 200 degrees centigrade, maybe 250, sometimes even around 300. So that it gets very hot to melt the plastic, and then the plastic comes out the nozzle. The metal plastic comes out the nozzle, and to cool things down as you're printing, there will also be cooling fans to solidify the plastic. Now, the plastic's coming out now. Sort of, you to really make the design right. Now you have to move this hot glue assembly, type assembly around. And we have so 3D printers will have some sort of mechanism to move the print head in sort of the X and Y horizontal directions. Oops. Okay, so it's a little bit laggy, but you can see how there's these mechanisms with the belts to basically move that print head to any point on this plate. So now that we have that in 2D, we still need to make things in three dimensions. So to account for this, moving up and down, we have another assembly that will move the print bed up and down, while you have the other mechanism moving the print head in the horizontal 2D dimension. Whoops. And so let me play a video of that. So the video is a little bit grainy, but you can see that the bed is slowly moving down. This is a time lapse of a thing being printed. So the bed is slowly moving down while the print head is moving around in 2 dimensions. And this, so that gradually, if you imagine like drawing, it's drawing with plastic over and over, layer by layer, to build up this solid object. So as I mentioned before, 3D printing is a very broad term. This specific 3D printing technology with the melted plastic and building it up layer by layer, it's called fused filament fabrication or fused deposition modeling. There are these 2 terms. I think one is like a trademark term or something like that. But this is the type of 3D printing that's most common for ordinary hobbyists. And there are different types of 3D printers that accomplish this whole process of extruding plastic and moving that print head in 3 dimensions. They accomplish it all by slightly different mechanisms. For example, you have some printers will move the entire print bed in 2 dimensions. And then others will move that print, the print bed is stationary, but that print head will move in 2 dimensions. So they're all slightly different, but they work by the same principle, which is that idea of melting down the plastic and drawing things up layer by layer. All right, so David?
Yeah, is there any questions about the technology about 3D printing right now? Feel free to jump in.
You can unmute yourselves or you just write it in the chat.
Yeah. Okay, well, if there isn't any, feel free to drop it in the chat. So I'm going to start with how FDM technology can be applied in real life. All right, there we go. Everyone see my slide all right? Okay. So the world of additive manufacturing, which is what 3D printing is called, because you're making materials up. So what are some of the uses? So I'm going to start with some of the personal uses. You can make parts from it. So this example on the left, this is actually on my rice cooker, because the rice cooker, the part of my rice cooker broke. So instead of spending $60 for them to fix it, I just printed it, because the files online, you just save yourself some money. And that is applying to so many other parts. So they've mentioned parts engineering, parts in real life, but also, if there's a furniture like on your house that's broken, just print it and, it'll be all good. And so the other ones are just, for fun. So this one, Mandalorian helmet, there's so many files online, and you can just download it, print it, and then, wear it. And this is the dream of so many nerds like me. We can just print toys without spending way too much money. But this takes a lot to get to this metal look, and we'll get to the post-processing in another workshop if you're interested, but there's a lot of sanding and a lot of painting involved. So the other one is industrial, right? You can make, one of the most exciting ones is prosthetics. You can make customizable, each person's hand can be different, right? Everyone can have a different Iron Man prosthetics if they want. And so, infinite possibilities. And also rapid prototyping. What is that is, sometimes you design a product and it might take a lot of energy in traditional ways to make that into reality. But with 3D printing, you can just, convert the 3D model into the actual thing and have it work. So it's really amazing. And it's very applicable in engineering and everything else. The last one is a little bit sad, but very personal as well. This, you can see, is a video of ISIS destroying cultural artifacts in Iraq. And one of the destructed things was this Mosul line, which is the cultural symbol of Mosul, the city of Mosul. But actually, this is a 3D printed object. This is a 3D printed replica. Because before that, before they destructed the line, people went in, 3D scanned the object. And so now everyone can have this 3D printed object in their house. So the link is down there if you're interested. But this is one of my particular interests because I love making these little replicas in home. I have a lot back here. This is a Nefertiti sculpture that also 3D printed. It's very easy and everyone can have access. So, every artist can have access to these technologies. Or you can make a little skull so you can see it's creepy in a video chat. So we talked a lot about all those technologies that are possible with plastic. What about some of the other materials that you've been hearing about? How about chocolate? How about cells, human cells? Well, yes, you can make that with 3D printing. And so here you can see right here, they're 3D printing with chocolate, right? Melted chocolate with pressurized tube. And you can make any shape of chocolate that you want. So, you can make that'd be the greatest Valentine's Day gift, wouldn't it? Have a very personalized chocolate. And then here it's a 3D printed heart. It's Israeli university, I think. But basically, it's using the exact same technology that Ken was telling you about, right? Having this material move in a coordination. It's like a hot glue gun, except here they're using cells suspended in liquid, except instead of using plastic. So I'm going to talk a little bit about another printing technology that you might encounter, but you might not, right? It's called SLA printing, stereolithography. And you can see here that instead of using plastic, here it's using resin. And so as UV light hits the resin, it cures. And instead of the hot glue gun squirting things on top, this one, it cures things on the bottom and it rises up. So you can see another image right here. So what are some of the benefits of this technology? You can make really intricate parts, right? If you want to make a small miniature, if you want to make jewelry, I've made a little jewelry with this. It is really cool. But it's really small, but also resin, if you've ever smelled it, it's disgusting. So we don't recommend you doing this at home, but it gives you really, really beautiful, intricate parts. So if you want to talk more about this technology as well, talk to us. So I talked a lot about all these different parts, that rice cooker part, these beautiful artworks that you might be able to get online. Where do you get all these 3D models? So this is a list of websites that I recommend and I use personally. So Yegi, the first website, is kind of like the Google of 3D models. And then Thingiverse, My Mini Factory, Sketchfab. I won't talk too much about these since I will share these slides with you and you can explore these yourself. But there's a lot of great free, and these are really free models that you can get right online. And my personal favorite is, of course, My Mini Factory Scan the World, where they're pretty much going into every single museum in the world and just scan objects. So there's even Yale has a lot of objects on that site. So you can check out their work. And yeah. So of course, you can also scan your own 3D models. And that 3D scanning sounds like a very intense, right? Very intimidating subject, but it's actually really simple. You can see on the image right here, you're just scanning things with your phone. Pretty much the principle is you're just taking like hundreds of photos of an object, and then computer kind of calculates, does all the work for you. And then so you have this just 3D model, and then you can print it. So if you have, I don't know, a toy that you really love from your childhood and you can't bring to Yale, you can just 3D scan it and then take it with you. Or you can scan your parents if they can sit still and print them if that's not too creepy. There's a great video on this, so I won't get into it, but it's in the slide. So check this video if you're interested in this. So now I'll hand it off to Miriam for the actual workshop part of how to make your own designs.
Woohoo! So now it is on to actually making your own 3D printed keychain. We're gonna use CAD. I believe there's a next slide for that really quickly before I jump into Onshape. First of all, was everyone able to successfully get Onshape from the email? You can just like a thumbs up react. So,
or if you didn't receive the email, because I'm not sure if everyone saw the sign up form where we collected your email, but if someone didn't receive the email, I guess mention that in the chat, and I'll send you an email with the link to download the stuff we need for today's workshop. Or if anyone had trouble registering or downloading, please let us know.
Mm-hmm. It looks like almost everyone got it though. So I'm gonna start sharing my screen and showing everyone Onshape. Let's see, find my screen. Wait. Okay.
Okay, Christina has some problems. Okay.
Okay, for MakerBot we will cover that after the CAD portion. For now, we're just going to use Onshape, which is just a web-based CAD software. So you can just open up a screen on your internet browser, go to Onshape, go to your account, and yeah. So basically, CAD, computer-aided design. It's basically what it stands for. It helps people manufacture or like design parts on a computer, and then those parts can become like real objects. So it started off as an engineering application, because throwback to the ye olden days when all engineering products, buildings, etc., had to be done with blueprints. It's basically, yeah, and they had to be drawn 2D, two-dimensional, like, and that's how you got the dimensions for everything. You could figure out like where things are supposed to be like placed in relationship with each other. And yeah, so how that started with the origins of computer-aided design is the first computer-aided design software was actually two-dimensional as well. And it is still in use today. It is called AutoCAD. And that is basically just like blueprint software, but on a computer. So you just draw maps or like draw like basically just like a two-dimensional drawings or of whatever you want to build. And that is why views often are very important in engineering, because you have a top view, side view, you can have isometric views, more advanced views, because that way you can try to capture three-dimensional objects on a two-dimensional sheet. But now, thankfully, with the rise of technology, the majority of CAD slash, yeah, like basically all CAD, except like you do have like AutoCAD and like you can still have like drawings and stuff, but everything else is all 3D modeling. And 3D modeling is very powerful because you can create basically any object you want on a computer, and you can basically just like rotate the screen, so it's really easy, and that's what we're going to go through today. So yeah, so you have your on shape. We're going to start with that. You can kind of see, I'm going to start with a demo. So this is what we're going to create. You guys can create, I just created the YaleMakes logo, but you guys can create whatever, let me rotate, whoop. You guys can create whatever little object or like image you want for your keychain. You can see there's a hole, you can ring it through your key ring. And yeah, so for really quick, how to maneuver around this three-dimensional landscape, because it can kind of be a little counterintuitive. A lot of times for like more serious CAD, if you're like making very complicated parts on CAD, it's easier to just use a mouse, computer mouse, because that way you use the scroll wheel a lot, and you like click in the middle, and that's how you can like maneuver around the space. But with Onshape, it's really nice because you can use just a computer trackpad. So zooming in and zooming out, you're basically just using like two fingers or like scrolling on a trackpad. So you can scroll out, scroll in, and that's how you can zoom in and out to different parts. You can also, wherever your mouse is, it's where the center of the screen is. So you can see I'm like zooming into this corner because my mouse is there. If I want to zoom into the other corner, just hover your mouse over it, and then it zooms in relation to your mouse. So there's that. Then there's rotating. For rotating, you basically just like right click and then move your like fingers or mouse or whatever around. Yeah, so rotating, if you want to see the back, you can see the sides, you can go around the sides. Yeah. So yeah, just right click, move your fingers or your mouse around, and that is how you rotate. And then for panning, this one's like a little bit more complicated. You have to click the control button on your computer first, and then right click, and then move your fingers or mouse around the screen. So panning is very important because like, let's say I'm here, I want to pan over, or like I have a flat face. I zoom in here, I want to pan to the hole. I just click control and then right click and drag until you get to the hole. Does that make sense? Just little maneuvering around. And if you have any questions, because it takes a long time. I've been doing CAD for like what, 6 years now, 7 years. So like it is very confusing at first. I totally know, I totally get that. So if you have any questions at any time, just like feel free to drop it in the chat. Cool, amazing. All right, so let's create our own. So you have we're going to create a document, call it keychain. So this type of CAD is called solid modeling because you're basically creating a solid object. There are other types of CAD. So we discussed, there's already the two-dimensional CAD. There is also CAD specifically for manufacturing. It's computer-aided manufacturing. And CNC machines, which is, it's like the inverse of a 3D printer, basically. So if you have like a metal object, like a metal bar, and you want to like create an object, instead of like adding stuff, the material's already there, so it's just removing material. So it's like, and like, or like I guess like artists, if they're like creating like a stone statue, it's basically that kind of concept, where it's removing material instead of adding material. Yeah, so that's more advanced, and just, you know, you can also like use CAD for metal specifically, but since 3D printing does not require any of that, we're just going to use solid modeling, and that's what this is. So we start off and we see our planes. Woo, throwback to math. Math is actually applicable. 3-space math. Woohoo! We love to see it. So yeah, so you have your top plane, your front plane, and your right plane. And this is going to be the base of how you maneuver around this space. You can also, eventually, once we get the part, you can hide the planes, because you don't want to hide them at the beginning, because then you don't know where to like start your sketch. But once you start your sketch, you can see the object, and these planes can kind of get in the way. So yeah, just know you can hide them and unhide them at any time. So we have this. And another important box, if you ever like get lost, you can just click on the box. You can click on any of the faces, and then yeah. So then that's also another easy way to maneuver is with this box. You can also move this. But yeah. So if you ever get like lost, just go back to isometric. It's kind of like your main view. So just click down here. Isometric is the first view. That's your basically just default where you start off. Cool. So let's start off making a sketch. Sketches are the most important things. It's fundamental to whatever you want to build, because first you got to sketch a 2D picture or 2D shape, and then you extrude that into a 3D shape. So these are going to be the two tools we use a lot. Sketch first. Once you have a sketch, then we're going to extrude it to make it 3-dimension. So I'm going to start a sketch. You can pick whatever plane you like. I'm going to pick the top plane. So now you can see the sketch is made on the top plane. So I'm going to click on the top plane just so it gets me to the sketch view, and it's really easy to make things. So we're going to start off with making a rectangle for the keychain. So if you see this like little down arrow, there's like different ways you can make a rectangle. Since it's the first object, I like creating a center point rectangle, because then I can click on the origin, go out, click, and then you have a square or something. Make sure once you do that, you exit out of this, because if you click somewhere else, you'll accidentally make another rectangle, which we don't want. So just click on the rectangle tool again, you exit out. If you actually accidentally make a mistake, you can, once you're not clicked on a specific tool, you can drag your mouse over everything, highlight everything, right click, and then you can delete. So back to normal. So if you ever, and you can also click undo if you didn't want to do that, redo. So you have those mechanisms for making the first rectangle. Cool. So we don't want this to be absurdly small or absurdly large, because we want this to be like a sizable like keychain, right? So we're going to start off clicking on dimension. Dimension is very important, because then we can actually choose how big we want to make this. Okay, so 3 inches is a little big for keychain. I think we decided a solid size to be like 2.5 inches or 2 inches, around there. It's also cool because CAD can do math for you. So let's say, I don't know, 3 minus 0.5. Woohoo! It automatically does it. So especially if people get into like more complicated like equations and like, oh, I want to make this like a certain size, you can add and subtract this, and multiply and divide, which is really nice. So yeah, woo, we have our first rectangle, and when it looks right, we're gonna click check mark, and that means it's done. So I'm gonna rotate to see this, and then so now that we have like a starting point in a shape, I'm going to remove the planes just so it's not in the way. And then we have sketch and extrude it. So click on extrude, click on the sketch, and then you can see you can actually like move this too to see like how thick you want it. And then here you can decide on the depth and everything. So I think a good size is 1/4 inch. I think you can also do, yeah, like 1/4. And then, oh, it does not do that. Oh, it does do that. Yeah, yeah. I personally like using decimals better though. Keep things, yeah. And then in the same like decimal, or I don't know, notation. Haha. Woo! We have a square. Squares are nice. We like squares. So this is going to be the basis of our keychain. Amazing. So yeah, we got this. This is really cool. There's some other. Is there any questions so far, or everyone? Yeah. Where do we find the dimensions part again? Okay, so you have a sketch. I'm going to show the sketch. Okay, if you double click on any object in your tree, this is called the tree, and then once you keep adding things, it'll keep adding onto the tree. So it starts off like or like default geometry for sketch and extrude. I double click on sketch 1, and then we have this. The dimension is right here on the toolbar. And it's nice because if you like hover your mouse over any like of these tools, you can actually see a description of the tools eventually. Yeah.
Is everyone able to make a square so far?
Okay, how we made the rectangle, yes. So you have your planes, we're able to click on sketch. So if you click on sketch, then you click on a plane, and then the rectangle tool is right here. So you just click on a rectangle. I normally down click on the little arrow here, click on center point rectangle, and that way you can start from the origin and make a rectangle. And then wherever you want, it can just be like anywhere because we're going to add the dimensions later. So just click anywhere. And then you have a rectangle. You can click on dimension and then change dimensions to whatever you want. I'm going to undo just because I already have a rectangle. Okay, yeah, this has already been, that's cool. Should I repeat how I made the rectangle from the very beginning? Or okay, are we all good with the rectangle? The square.
I think if you could go over the rectangle from the very beginning, I think that would be
Should I do it
helpful.
from the beginning? Okay.
Yeah. And if I don't know if anyone is having issues with the things being laggy, but if you like, I think if you minimize the zoom window a little bit, that might help the CAD load a little bit faster if it's lagging.
Okay, so just so you know, there's a rollback bar here. You can actually move it around and then everything disappears. I might just delete this quickly because I can make it again really easily. So delete, cool. So your very beginning. First thing we want to do is create a sketch. I click on sketch, I click on any plane I want to. I'm going to click on the top plane, which is this one. You can see it highlighted in orange or yellow. Once that sketch is there, you can see sketch 1 is made. Then I'm going to click on the top right here of the little cube in the top right corner. Once I have that, I'm going to click on the down arrow, click on center point rectangle. You can see it's being used when it's highlighted blue. Click on the center, click on any like arbitrary place, and then you create a rectangle. After that, I'm going to click on dimension, which is like right in the middle of the toolbar on the top. I'm just going to click on a random side. And then as soon as I click on it, you can see that this thing shows up. And then it's just like floating because I can put it wherever I want to. I'm going to click again just to place it. And then that automatically gives me the option to change the dimension. I'm going to do 2.5, 2.5 inches. I believe this is a square, should already automatically do it. Or no, it's a little bit different. So yeah, click on the bottom side, bottom edge, same thing, 2.5. And then you have that. Cool. And then once you're done, so your screen looks like that, click on the green check mark. And then we can move around. I'm gonna get rid of the planes just so I can see more clearly. My screen is clean. Once we have the square, extrude is right next to sketch. You see right there. I'm going to click on that button. I'm going to click right on the sketch, and then it's going to automatically show up like, oh wow, it's a cube now, or it looks like a cube. And then I'm going to change the depth to 1/4 inch, so 0.25. I'm going to click enter, and then check. And then here's the rectangle again. Cool. Okay. All right. So we're gonna move to the next step. So right now, could probably hurt people because the corners are pretty sharp. So you don't want to like poke people's hands when they grab their keys. That's never fun. So we're gonna use another tool that's very useful called fillet. A lot of people call it fillet. I think it's fun. Call it fillet. But basically, this actually just rounds the corners, so you don't like poke people's hands or like and it just looks nicer. Personally, I think so. So we're gonna click on fillet, and then we're gonna maneuver around. So we click on each of these edges. So if you click on one, you can see it automatically rounds the corner. And then we can change the radius. So you can keep it at 0.2 inches. I think that's fine. You can change it if you want to make it smaller or like smaller radius or larger radius. I think 0.2 works nicely. So yeah, click on one edge and then just go around. So rotate your part until you click on all of the edges. Cool. So now we have a square with rounded edges. And then when you're done, you can click on the check mark. If you accidentally click on the check mark or accidentally exit the screen, just know you can always double click on the part, and then that just puts you back on the editing screen. So you can see this again and choose the edges. If you accidentally choose an edge you didn't want to, you can just click on that edge again. So like for instance, you accidentally choose like the top edge. You're like, oh no, we don't want that. Yeah, just click on the edge again and then just unselect it. And then if you ever get lost again, you can just click on the little cube on the top right corner, on the down arrow, go back to isometric, and that gets you to like a really nice view.
How's everyone doing so far? I know this is a little bit fast, especially if you haven't done CAD before. And especially with things being online, it's a little bit tougher to follow along. So please, if you have any questions, post in the chat, or if you're comfortable unmuting yourself and asking.
Okay, so rounding the angles is fillet. It is the right here in the menu bar. And you can see a little like cube with a rounded corner. That's the one.
We have another question about getting the right dimension.
Oh, it is tough. I feel that. I totally understand that. Okay, for sketch, for getting the right dimension.
Sorry, can I just also interject? The dimensions part, it's important here, but also when you're printing it out, eventually you can edit it in the next software. You can make it as large as you want. You can make it as small as you want, any step of the way. So it's like this one is, scaling one model, but you can scale it however you want. And that's actually another benefit of 3D printing. You can make things as small or big as you want. Yeah, exactly.
Yeah, so like honestly, even if it's like absurdly large in the CAD, you can scale it down in the next software that we'll use right before you 3D print. So like this part doesn't matter too much.
Miriam, could you show the dimension feature
so I'm
again?
gonna right click on sketch one because that is how I go back to like the editing mode. I'm going to click on the top so I can see the sketch. And then dimension is a tool that's right on like towards the middle of the toolbar. It looks like two lines with an arrow in between the lines. And then if you click on that, then you can click on any area of the screen or of the part. So I can even do like different like angle dimensions, etc. But for now, we just want to do like an edge dimension. So you just click on the edge, and then you should see a little like bar come up, and you can click again, and then that'll give you the dimension. I'm just gonna... Okay. Cool. And then for the, fillet, click on this, and then you'll get a screen that looks like this. Oops, there we go. Yeah. And then you can see everything, every like edge in orange is what is there previously. You can kind of see like a transparent, like, oh, what the part looks like before the fillet. And then you can just unclick or click on the edges to get that corner rounded. Cool. I'm going to move on. But yeah, again, use the chat if you have any questions. So we're going to create another sketch. This time we're just going to click right on the face because you can make sketches on faces. We don't need to click on the plane again, which is nice. So you can see a sketch. I'm going to go to top view. And then this is going to be really easy. You're just going to create a circle. So we're just going to click right on the circle. It's really nice because if you like kind of hover over where like the center point is of like the rounded corners, you can get an exact placement like right there if we want a hole there. So I'm just going to click on the center, click anywhere else, and then I get the radius. Again, we're going to use that dimension tool right here. Since there's no like edges of a circle, you can just click right on the whole circle and it automatically sees that it's the radius, and you just click on the circle anywhere, click somewhere outside the circle, and then we can edit this. What's a good hole size? Do something like that because we don't want to be too close to the edge, otherwise it can like break. We can also just like move this. So this is constraint, but if we want to like make it just like more inside the circle so it's not too close to the edge because we don't want that part breaking off. Because keys go through a lot of movement. So I'm actually gonna make this just like somewhere in the middle. Use that dimension tool. Gonna do like a 2. And then you can also use dimensions you can like have 2 points be a dimension. So if I click on this, and this is a control click. There we go. Yeah. So if you click on the edge of the like square and click on the center of the circle, you can get a dimension. Let's make it like 1/4 of an inch or something. And then same thing, click on the edge, click on the circle, and then it automatically gets you this. Click anywhere else to place it. And you can always change it if you don't like it later. So if I want to make it bigger or smaller. Cool. Is there any questions there? Okay. Does everyone see this little cube in the corner where my mouse is? So this cube is just an easy way to like orient your view. So since I created the part on the top view, if I have this view, because generally it's like the default view, I just click right on the top and you can see the top is highlighted, click on it, and then it gets me that view.
I also want to point out, speaking of this view, is that a lot of the 3D printing softwares also have the similar layout. So getting familiar with one of these software will pretty much make your transition to any other software really, really easy.
Okay.
So it's not all intimidating.
Mm-hmm. For sure. I'm just going to make the circle again because the dimensions can get a little confusing here. So I create a circle. If I click right on the edges of the circle, I get the radius. So boom, radius 0.2 or something. For the dimension across the gap here, basically, so from the edge to the circle, I make sure that dimension is still highlighted. If you're not sure, you can unclick and re-click. So, okay, if it's blue, that means I'm using it. So I hover over the edge. Once I see the edge is like orange, I just click on it, one click, left click, and then I click on the center of the circle right here, another click, one click, and then it automatically notes like, oh, wow, okay, so we want to create a dimension between those 2 points. You can move this around wherever you want. Once you want just to place it, you just click again, left click, and then you can make this whatever dimension you want. So same thing on the other side, hover over the edge until you see it highlighted orange, click on it, left click, hover over the center of the circle, click on it, place this anywhere else, you have to click again, and then it automatically highlights the value, enter whatever you want, and then boom, we have that. Cool. All right, I'm going to finish a sketch. Once it's finished, I see that it's a sketch, but it's not extruded yet. So we're going to click on extrude. We're going to click on the little circle, and then we're going to click remove because we want to make a hole. So click on remove in the little menu. Here, when it says, where it says type, it says blind to begin with. That lets you basically choose where, or like just choose like a value you want to extrude it as. We're going to click on through all because we want the hole to go through all the parts. So remove, through all, and then check. And then we can see, oh yeah, there's a hole. It's white now. It's not filled in. So we have the start of a keychain. How's everyone doing? Thumbs up, thumbs down, any questions? Yay. Woo. Cool, cool. All right, and then this is the fun part where you get to design your own keychain. I'm going to create the YaleMakes. Oh wait, there's a question in the chat. Let me see.
Yeah, can you make another hole?
Okay, yeah, I will make another hole. So I'm just gonna delete just to make another hole. So the sketch is there. I'm gonna click extrude, which is the exact same tool we clicked to make the whole thing. Extrude is cool because you can either add material or remove material with extrude. You just have to specify it in the menu. So we're just gonna click on extrude again. Right now it says new. If we click on the little circle, it automatically thinks to add it, but we don't want to add material, we want to remove material. So we're going to click on remove after clicking extrude, clicking on the circle, then click remove. And then instead of blind, we want to go through all. And then automatically detects how thick the part is, and it goes through every like portion of the part. And then once you click remove through all, click on the green check, and then we can see there's a hole. And then to make the have the screen, or like have the view be default view, once again, we can just go to the right corner, top right corner, see this little cube in the little drop down, click isometric, and that's kind of your generic view. And then you can always rotate from there. Again, rotating is right clicking and moving around. And then panning is control, right click, move around. All right. So let's get to designing this. So we're gonna make another sketch right on the top. And then once again for a view, click on top view so you can see this whole part. You can make whatever you want. You can make your initials. Yeah, this one, like, dimensions don't really matter here because it's like, yeah, yeah, because like the others, we do want to make it like a size that's like fit for a keychain, and we do want to make sure like the hole isn't too close to the edge. But for here, don't worry too much about dimensions. You can just make whatever cool design you want. You have just lines. You can use lines to make like anywhere. Like, woo, or make like a cool, I don't know, like moon. Does not look like a moon. I don't know. I don't know. This cool polygon. Yeah, so you can use lines. Whenever, if you want to delete something, make sure you're not clicked on a tool. So make sure everything's white. You can just drag over, you can delete. And yeah, stuff like that. There's also like a center, like a center, like, what's it called? Circle. Let's say I want to make like a half circle. I can just click anywhere. You can see a lot of like reference lines just show up. So I'm gonna make like a whoop, half circle. So one thing to note that CAD is really finicky about is that you always want to make sure your sketches are closed. So you can never have like an open sketch where the computer won't know what to do. So we're gonna use the trim tool. The trim tool is very powerful because it lets you basically create more advanced shapes that aren't just rectangles and circles. So the trim tool looks like little scissors. It's right here. You just click on trim, and then you can hover over any line. It'll basically just delete that line. So if I want to make that half circle, I made the whole circle line in the middle, and then I want to delete this edge. So trim, and then boom, it's gone, which is really good. And woo, that's what we want. Let's say the problem where CAD arrives, let's say I accidentally like delete this. You're not going to be able to extrude this part because there's a hole, and CAD's going to be like, what should I extrude? There's a hole. So just make sure there, if you ever have holes, you can either just like add more lines, like, oh, I accidentally create a line, or there's a hole, just add a line to make sure the part is whole. Dragging shapes around.
Yeah.
Let's see. There's a lot of constraints, so it's a little hard to drag shapes around. You can make them like bigger or smaller. Unfortunately, yeah, it's not like the most intuitive like design software. It's not like Adobe, because you have to be like a little more precise for CAD.
What you could usually do if the shape is in the wrong place, you just delete it and put it somewhere else.
Yeah. Okay, so yeah, the easiest way to drag shapes around is to not put it on the origin. I put it on the origin, so if I like delete everything, no, I didn't delete. Okay, try that again. Delete. Cool. Easiest way to create shapes is just to make sure it's not on the origin, because if it's on the origin, it constrains to that origin, so you can get kind of like funky things. So just put it anywhere, a circle, and then just make sure you're not clicked on the tool so you don't create like more circles. Then you can drag the circle around. I actually want to make a little tree. That's fun.
We have a question about dragging text around. Where also, I think text might be going over text might be helpful if people want to put their initials.
Let's go over text. Smart. Yeah. So you have your text. Create a text box, and then YaleMakes. Wonderful. So then you have your text for, oh wait, I accidentally did not click out of text. I just have to remember. So for dragging text, just make sure you click on one of the outside points. Because if you click on the middle, for some reason, CAD's weird software, it doesn't like being clicked on the middle. So just make sure one of the outside points is highlighted, and then you can move it around. You can also make it bigger, and I can't, just moves it around. But yeah.
Also, when you're designing things for 3D printing, um, one of the things to keep in mind, and this will take practice, but one of the things to keep in mind is, not making things too detailed or too small. So when the printer goes to print the part, it becomes too detailed for the printer to print. So for this, for example, like I would recommend maybe instead of writing out a whole bunch of letters, if you limit it to say your initials, for example, it may be easier for the printer
Mhm.
to print.
Imagine it as like if you're drawing a essay, for example, with a big marker, right? It's very, very difficult. You can change the nozzle. So there are ways so you can make really, really intricate things. So for example, if you use a little pen, you might be able to. So that's another topic. But yeah. And then regular nozzle is too big. It's like writing a whole small essay with a big paintbrush.
The easiest way to make text bigger or smaller is to just make the text box bigger or smaller. Sometimes it just helps to delete it because sizing can be a little bit weird. Just make like a sizable like text box. My S key is sticking for some reason. I don't know why. Oh, it's a little too big still. Okay. Third time's the charm. There's text box. Okay.
How's everyone doing with adding things to the keychain? I know it's a little bit tough with doing this online.
Yeah, because we can't be there to help out in person.
Yeah, and sort of looking over people's screens and
Yeah.
having real-time feedback.
Uh-huh.
If any of you need to screen share, obviously welcome to.
Yep.
Yeah.
If you're running into any problems.
Yeah, we're small enough that like we have like, what is it, 10 people here, so it's small enough that if you're comfortable doing so, that's totally fine.
Should we move forward with the 3D printer part just so we can get back to this a bit later?
Yes.
Yeah. And then I'm just gonna create really quickly this cool like infinity thing. Just make sure, yeah, the parts are like one part. So you have like text, everything's like outlined. So don't have any open parts or like any open segments basically. So you have this, same thing, you can just extrude, click on all the parts. And then for this, you can add material. And if we rotate, we can see, oh, it's like adding the whole face, gotcha. You can just, I think removing material might be easiest. It's too much. And yeah, so whenever you get red things, that's when CAD's being like, oh no. So that's never fun. It can be very complicated. Like to this day, I get like lost. So if you ever hear engineering students complain about CAD, that's why.
I think you selected the rest of the face. And
I say select the face. That's what it is. Yeah. So see, even I make mistakes. Okay, so don't select the face. That I accidentally did that.
Yep.
There we go. Faces of sketch 3. Aha. So yeah, there we go. My bad. There we go. So yeah, I believe you can also just from extrude, just click on the sketch from the menu, and that way you're not trying to like accidentally click on the wrong part. Yeah, that's way easier. Do that instead. So you can either add material. So let's, if you want to like have this be like an outward extrusion, just click on 0.2 and then, oh, it's kind of thick. Yeah, so then you have either the outward extrusion or you can do an inward extrusion, which if you remove material, there we go, you can see that inward extrusion and then click done and woo, cool design. And yeah, you can, if you ever want to edit the sketch, you can always just double click on the sketch, gets you right to sketch view. And then you can keep editing it to your heart's content. And then again, back to default view. All right. Amazing. And even like if you want to keep working on this afterwards, like feel free to always shoot us a message. You have our emails. We was all CC'd in that email we sent for YaleMakes. So feel free to just like directly send us an email. We can chat with you through Zoom one-on-one and help you out with your designs. So yeah.
Okay, so now I'll wait, Miriam, can you just show one more step of how you export the thing to STL?
Smart. Yes, I did not do that. My bad.
Yeah.
Yes, that's very important. Mm-hmm. Yeah, so actually exporting. We can. Okay. So an easy way is to just go back to like your thing. You can share. Wait, no, you have to export. I normally, okay.
I think, Miriam, sorry,
yeah.
for this one, this model, you can just right click on Part Studio on the bottom.
Oh, gotcha.
On the bottom, yeah. And then,
oh, there's a Part Studio, yeah.
And the left bottom left corner. Yeah. Part Studio, just click on that tab.
The tab.
All right.
That's right. Yeah, there you go.
Yeah.
Yeah, there we go. And then you can make this STL.
I would recommend STL.
Yeah.
So STL is the file that everyone will use when you're downloading something from online, and it's the easiest thing to put into a 3D printer software.
Mm-hmm.
All right.
Yeah. So then you can export that, and then
so
it just downloads automatically. Mm-hmm. And then you have the part, and yeah, that's where you put it into the next software. Mm-hmm.
And I'll take over the next software. So here we go. Oh boy, we are at MakerBot Print. Is everyone able to pull it up?
Also, just so you guys know, yeah, the SEED, Center for Engineering, Innovation, and Design, they have also a 1 hour long workshop where they go specifically over the software and they show you how to use it. So if you ever want to make like 3D printed parts when you're on campus at the SEED, just sign up for a MakerBot printing tutorial, and the SEED will also go over this.
But I'll just go over some of the theory of when you're trying to print now. It's very simple. You can just drag the thing in or add the model in, and then adding the model into it. And it's as simple as here I was talking about scaling, and you can make it as big or as small as you want. So here if I want to make it 50 millimeters, it can be very small, and I can make it very big. So I'll stick with 100 now. That's best for demonstration purposes. And so once the model is in, there's many ways that you can arrange it. So you can, oh boy, you can see my computer is not handling 3D models particularly well. But over here at arrange, you can center the model. So why do you want to center? Because the 3D printer is pretty much designed for the center to be the best. And in case you run into any troubles in the edges, so having center is the best. Okay, so some of the important stuff we should be going over is infill density, shelves, and layer height. And I would turn your attention to my video right now, if you can, because I'm going to be showing you some stuff on Zoom. So look at my beautiful face on Zoom, and I'm going to be demonstrating you what these different things mean because they might seem very abstract in the beginning. So this is one of the models I was talking about, right? This is a Kuros in the Getty Museum. And you can download it, print it. But here I'm going to be showing you, and please don't be embarrassed. I'm very embarrassed because yeah, it's a naked woman. Yeah, just naked guy. Ignore it. Best for demonstration purposes. Okay, so I split them open, right? And so now we have a different part. We have a closer look at this model. And so here you can see the stuff in the middle. That's what we call infill. That's what we call infill. And why do we need this? Well, because if I squish it, if there's nothing in the middle, it would be like a vase and it would be really, really weak. But with a strong infill, it can squish it, no problem, right? Right here, you can see there's still infill. And this infill is around, I think maybe 2 to 5%. It's not a huge infill amount. So if we look up here on my screen, we will see the infill density. So at a 0% infill, that was what I'd be saying like a vase. But a 100% infill would be solid, right? This whole thing is like a block. Do not do that, but it's a waste of materials unless you want that part to be really, really rigid. If you want it to be a solid plastic part, do that. But 3D printing material is cheap, but it's not, it's still money. So I would recommend for a regular part to have 5% is good enough, unless you're going to be straining it a lot. If you're just sitting at your table, 5% is perfectly fine. So the other one I'm going over is shells. What exactly is shells? Well, it's this thickness, right? How thick do you want this wall to be, right? Some parts you want it to be really strong, while you want more shells. And some parts not necessarily. You have one shell or two. And why is that? Well, because, you're saving materials. You can save materials by having thin walls, but I recommend 3 shells just so the part is rigid and lasts a long time. The next one's layer height. Oh, sorry.
No, if I may interject, all these things in terms of saving material also will save you a lot of time in print during printing. That's one of the biggest concerns, and also I think personally one of the misconceptions I had about 3D printing when I first started, that I thought it would be really fast, but sometimes you could have a small part, if you have the infill density too high, or you're putting in your shells are too thick, it will take hours and hours and hours to print, like on the order of like 10 or 20 hours. So if you try to play with those settings and get them down to, find a good balance between, strength and material savings, you could also reduce the printing time significantly as well.
And just to show you how long things might take, this little thing that I just printed, it's a sculpture. And this thing took me about 30 hours. And so it takes a long time. This is something you might not be able to do at the scene because they have a 3-hour limit. But I'm just saying, if you want these bigger ones, they take a long time. And one of the other things that will add significantly to time is the layer height. Basically, how detailed do you want the print to be? Because as you've seen from FDM printing, that things have these lines on, right? Layer by layer. And so you'll see these little lines, but how can you minimize that? By reducing the layer height. So here we have an example. Here is a 0.05 layer height, and here is 0.2 layer height for the same model. So you can see that this one is so much more refined, and the small details will show on the side, whereas this one is going to be blocky little lines. So that's kind of the basics of some things that you want to manipulate as you're going into printing that will really change your print. So all of that can be manipulated in the print settings right here. So here you can see infill density, the infill pattern. What I just showed you is this diamond fill, right? This is rectilinear. It's another way to call it. It's very straightforward. This is the best way, in my opinion, for a rigid part. but there's also other infills that make parts more flexible. For example, this is a gyroid infill. You don't need to bother with this right now, but this is another material, but it works perfectly because this thing gives you a lot of flexibility that this thing might not. But also you can get really creative and have sharks. Yeah, let me see if I can pull that up. It's very ridiculous, but yes, you can have shark infill. This is just to be ridiculous. And so here you can have layer height, and then this support thing, I'll get back later, but now I'm just gonna put none. Let's see how this looks. So you click here and it generates a preview. And so this one will give us, okay, it's gonna take a long time to process. It's fine. So this will give us a preview of how the printer is going to be able to print it. And eventually, all you need to do is export that file here and load it into the 3D printer. So at school, you can do it on the school laptop, or you can just put in the USB drive and the 3D printer will recognize it. So here, let's see, we're getting closer. There we go. You can see the path of how the 3D printer is printing it. So let's go over it again, bottom path. So you can see it layer by layer with sharks in the middle, very ridiculous. And layer by layer, and then you can see the text right there. It's building it on top of sharks. And so that's how your keychain is going to look. Oh, by the way, the navigation of this software, right click for this rotation, shift plus right click is panning around, and 2 finger zooming in. Yeah. Anyone having trouble with that, let me know. So you see this, but here is what I was talking about, the support material. So think about what Ken told you about 3D printing. Would this work? Can a 3D printer print things out of thin air? It can't, right? So how do we do this part? Well, that's when we need support. Support type, let's say breakaway support. So what support does is like a scaffolding for the part that you can just remove later, and so you keep this part. And this is what we call overhang. And support can help you with that. So it's still loading. Is anyone having problems with this?
I think there's some people who are saying the software requires them to add a printer in order to even use the software.
Oh, right.
Yeah, I think in the interest of time, if you aren't able to follow along for that reason, I would say since we don't have that much time left, I would say just take a look at what David's doing, and then if you need to use this in the future, we'll be sending out a recording of this, so you can rewatch it. And as Miriam said in the chat, also the seed also covers this if you talk to their staff or if you attend one of their 3D printing orientations.
Also, just if you want to play with it, you can just add an N-connected printer right here. So add a printer, N-connected printer, and then what seed uses Replicator Plus. So you can just use that if you want to play around with it. So yeah, oh boy, got out of support. Let me cover slightly how you would get a model online and how you would drag that in, just because it's fun. And when screen sharing is paused. Not sure what's going on here. Okay, well, I don't think it works on other windows, but basically you download the model, you drag it in. So this is a Nefertiti bust that I downloaded. And you just print it. And then, so here you see the same problems with the overhang right here, right? You can't print this jaw out of thin air. So it needs a support right here.
Could you, yeah, David, could you also, with this model, show if you want to scale it, how you would do that?
Right. So,
sorry.
Oh. Boy, okay. I just want to point out the overhang part right here. Oh, no, this one did not generate overhang. Okay, never mind. Breakaway support. So scaling this model, I would not, if you're going to be making a big model, you can't scale it outside of this box, right? This has a constraint. You can print as big as this area is, but there's a lot of other ways to cut up the model. I think that will be a separate other workshop, but basically the software that I use is called YaleMakes. See, I can find YaleMakes. Sorry, this Zoom is blocking all the
lagging.
Yeah, the Zoom is also blocking everything. I can't see them. Okay.
Yeah,
it's this software you can use and then split up a model.
Yeah, but could you show like scaling it down, like if you want to make a mini version of this?
So you can just click this in the end, scale, and then make it as big as you want. So here you can make it 10. And so you get a really mini Nefertiti bust. You don't want to do this. It will come up like a dot. It will just a clump of nothingness. Don't do this.
Yeah.
So
and you can scale either by percentage. So I want to scale it up by 15%. So you say, okay, well, I want 115%, 115%. If I want to say, I want it to have specific dimensions, you can scale it by dimensions too. Ron, if you also notice right now, David has uniform scaling checked, so that will scale all the dimensions by the same like percentage, right? So if you, but if you want to like say stretch out a model and make it super wide, right? You could uncheck uniform scaling and scale one specific dimension to make it wider, like taller, or thicker. I don't know.
Yeah.
But each of the three, yeah, like that.
So this is what happens if you scale Y. Oh boy, look how beautiful that is. It's breaking my computer.
It's also lagging because I think you're outside of the
print
bounds.
range.
Yeah. So I would suggest not.
Don't do this.
Going overboard, because then the program will freak out.
Yeah. People have done amazing optical illusions with this kind of scaling, right? Stretching a sculpture like this. So now it looks normal, and then you change your perspective and it looks wacky. So isn't that pretty? Okay, hope this one works now. Nope. But basically, I'm just here to show you how support works. Basically, overhang right there. Is there any questions? I know that was a lot of disorganized information. Sorry, my computer is very rebellious today. All right, so you can see now the difference here. Support. Yeah. Okie dokie.
And the support material, by the way, that's the printer calculates that in a way where it's easy to remove. Like if you grab a pair of pliers or some tweezers, you can pick it off fairly easily. Okay, yeah, and as we mentioned before, this is this workshop will be recorded, so if you need to come back and watch things, and also I'll send out a bunch of other links to other helpful resources, so you can sort of explore more on your own. Let me go back to the slides. All right, yeah, we have like 3 minutes left, so. Oh no, I'm on the wrong slide. Okay, yeah. All right, and just to close off the workshop today, the question is where can you access these 3D printers? So as we mentioned already a few times, the Seed is going to be the go-to place if you want to print on campus, and to access the 3D printers, you need to become a member of the Seed. Which, so in the past, under non-COVID circumstances, you would show up for, I think it's like an hour-long orientation, and they will walk you through like sort of the ground rules of using the space and intro, the different tools you have access to. And then in order to use the 3D printers, there's a separate training. I think it's like 45 minutes where they go over, they actually go over this MakerBot software as well. So based on those two trainings, you can get access to all the 3D printers. And I think someone also asked in the chat earlier, how do you get these models onto the Seeds printers? So the Seed has the Seed computers have this software installed, so you can say like just log in, put whatever model you want to print. So remember that STL file, either that you downloaded from a website or the STL file that you exported from Onshape. You can load that up to the software on the Seed computers and their USB sticks. And the Seed staff have more information on this. This year,
for orientation and trainings, make sure you go to Yale Connect. They use Yale Connect a lot. So just go to Yale Connect, look up Center for Engineering, Innovation, and Design, sign up. It's really easy.
Yeah. This year actually might be a little bit different. They have more specific information at this link in the slides, seed.yale.edu/COVID-19. And there are information, they have information on how getting Seed membership will work this year and how trainings will work. So that's, something I'd highly recommend checking out the Seed. If you're not a member yet, become a member so you can use the materials there and the tools there. Another thing is, if down the line, if you do want to sort of look at getting your own 3D printer, there are, I've just put up a few examples here of some very common 3D printers for hobbyists, and these we're obviously not going to recommend any specific printers or anything, but this is just to show these are generally the types of things that people will be using, and I would say the main takeaway, if you are looking for a 3D printer, looking at is to really think about what features you need and what will you be using the printer for, but also thinking about if there is enough documentation online, are there enough resources online where you can say, I'm having trouble with something. Is there a forum where I can ask my questions, or are there a lot of videos made by people who have encountered this problem before? Because a lot of the 3D printing stuff, a lot of it is trial and error that you figure out on your own, or you read about what other people have done. So in that sense, having a printer where there's a lot of that's common enough, where there's a lot of documentation online, is very helpful. But again, this is only if down the line you want to look at getting your own printer. And I would say for now, right, stick with using the Seed as your sort of go-to place for experimenting with 3D printing.
Well,
Okay.
if you are going to be shopping one, do let us know so we can give you some advice. As from a friend, not representing Seed or YaleMakes. Any personal advice.
Okay. Yeah. Thank you everyone for coming today. It's great hosting this for everyone. We hope that you're able to learn something today, and we'll be sending this recording out along with some links. If you're interested in joining our Slack, here is our QR code and our link, and we can answer any further questions there.
Thank you. We hope you learned something. Yay.